Welcome to the second module. This is a continuation on how to build and understand a user-made function. Here I'm going to show you how to use function prototypes to better structure your program. You're also going to learn how to take a value from one function and send it into another, and then how to return a value back to its caller. We'll also be taking a closer look on the declaration of a function and its parameter list to have a better understanding of them, and how to create a Boolean function for validating statements. Previously, we learned that the function definition goes before the main function. This is because the compiler needs to know the information that's in the function header before reaching the function call. Another way so that the compiler knows this information is to place a function prototype, also known as the function declarator, before the main. In a void function, the function prototype will be almost exactly as the function header, except it ends with a semicolon. Here we have two function prototypes, one on line 5 and another on line 6, letting the compiler know there is a void function called first with no parameters, and another void function that's called second with no parameters. And then the first function that we have defined is the main function, as it's the starting point of most programs. This makes the program simpler to read. This program here starts out on line 10, printing hello from inside the main, and then on line 11 there's a call to function first. Remember that this time around we have the function definitions after the main. So let's jump to line 19. Here this function prints hello from inside first, then returns back and continues on line 12 to print we're back in the main. Then on the following line there's a call to function second, and its function definition starts on line 24. Function second prints hello from inside second, returns back to the main where it left off, and prints we're back inside the main, and the program terminates. Remember that when using function prototypes, keep them in order in which they are being called and define them in the same order as they are declared above. This is going to keep your program organized and make it much easier to follow later. This program demonstrates how to send a value into a function using parameters. When a value is sent into a function, it is known as an argument. In the past, we've sent literal values into a function using the math library. For example, if you're looking here to your right, we have the POW function receiving two arguments. The first argument is the number 2, and the second is the number 4, and it returns 2 to the power of 4. Now, in creating your own function and sending a literal into a function, you place a literal inside the parenthesis of the function call as seen a moment ago with POW. On line 12, there's a call to the function displayValue with the literal 5. In the prototype, you must declare the data type of the argument. In this case, the argument is 5, and it's an integer, so we write int inside the parenthesis of the parameter list on line 7. The displayValue function definition that is called is on line 20. Here, you're going to notice that in the parameter list, the variable num has been declared an integer. This is because when you send a literal into a function, in the function header, you must declare a variable to receive it and store it. Remember, the data type of the value being sent into the function must be the same as the one declared in the function prototype and in the function header. So now, for the function displayValue, the variable num contains the number 5, and this function will print the value is 5 and returns to its caller. On line 15, we have the same function being called, but this time the argument is 8. When the function is called, it redeclares the variables num, but this time with the argument 8, and the function will print the value is 8. Remember that when sending a literal into a function, always write its data type in the prototype parameter list, and there must be a variable declaration in the parameter list of the function header to receive the argument. If not, the program will have an error. Aside from sending a literal as an argument, you can also send a copy of a variable into a function. This is called pass-by-value. To do this, you start by writing the variable name in the parameter list of the function call as you would the literal. And what's going to happen is that when you send a variable as an argument, a copy of that argument will be made, and any changes done to it in the function will not affect in any way the original argument. Also, the variable that is being declared in the parameter list of the function header to hold the argument being passed does not have to have the same name as the variable in the function call, and more than one argument can be sent into a function. In this program, we're sending three values into the function displayValues. On line 13, you're going to see that the function called displayValues with three arguments. First is num1, an integer containing the value 2. Then there's num2, that is a double with the value of 4.4. And last is num3, a double with the value 6.1. When using multiple arguments, each one must be separated by a comma. In the function prototype on line 5, it says that displayValue is a void function with three arguments, two integers and a double. In this case, num2 isn't an integer, it's a double. So what happens is that it's going to automatically convert it into an integer for this function. Now in the function prototype, you have the option of writing the variable name for purposes of knowing what you're sending without having to go down to the function call or function definition to find out. But the compiler doesn't need that. It only needs to know the data type of the arguments. Down in the function definition on 17, you'll notice that three variables have been declared. That's because you must have a variable declaration for each argument being passed, and each one is creating a new space in memory to hold a copy of the original argument. Now in the prototype, remember that the second argument being passed was changed to an integer. In the function header, the declaration for the second argument must be exactly the same as in the prototype. So if it's not declared as an integer, the program will not run. By now, you'll also have noticed that the names have changed. num3 now holds argument of num1. num1 holds the argument of num2, and num2 holds the argument of num3. And when printing the following message inside displayValue, it will read, the value for num1 is 4, the value for num2 is 6.1, and the value for num3 is 2. This right here on the left is a simple program. Let's jump to line 9, where we have num being declared an integer and initialized with the value 5. And in line 13, there's a call to function changeValue, and it's sending num as an argument. On line 21, we have the function header for changeValue, and in the parameter list, I declared a variable called num to accept the argument passed. On the following line 23, num is assigned 20, and the program prints the new value of num is 20, and then it returns to its caller, and the following line prints we're back in the main, and the value of num is now 5. What happened here is that the variable num on line 17, when printing that last statement, still holds 5 as its value. Inside the function changeValue, we did change the value for num, but this integer value num is not the same as the one in the main. A new space in memory was created with the same variable name to hold the value of 5, and when it changed, this was not visible from any other part of the program. The scope of the function changeValue was to create a new integer variable called num, and to print the statement, the new value of num is 20. Once that is done, any space in memory that this function occupied will be erased from memory. And if this function is called again, it will redeclare an integer variable called num with the value of the argument passed in memory, and as soon as the function terminates, again it will all be erased. The scope of this function is not seen anywhere else in the program. So when num prints on line 17, it will print the value 5, as it never did alter at any moment. In this program, we're going to learn about the return statement. Up to now, we've had a return statement in all of our main functions. It returns 0, an arbitrary value that just signifies a complete run. And for it to be able to return the integer 0, the return type of the function main must be an integer. A function can only return a value of the same data type as the return type of the function. If the data type is different, then the value will be automatically converted if allowed. In the main, num1 is declared a double, and for this example, I gave it the value 0. On line 12, we have a call to the function logarithm with num1 as an argument. In the function definition on line 19, it checks to see if the value entered is 0 or less. If so, it prints, the answer is undefined. And up next, on line 22, we have a return statement with no literal next to it, like in the main. Here, what happens is that the return statement causes the function to terminate, and it returns to the caller to continue where it left off. The return statement is useful for terminating functions when they are not needed anymore. And because there is no value following the return statement, it means that no value is returned. So the return type of function logarithm has to be void. Void being the data type of the value that is being returned, signifying that there is no value. If the value that was passed as an argument to logarithm were larger than 0, then the program would continue on line 24. Here we have the function log receiving num1 as an argument. The math functions such as these contain their definitions inside the math library. What this function does is that it gets the logarithm for the number sent as an argument and it returns it. That's right, all math functions have a return statement. And if you're programming and you put the cursor over the word log, it will tell you that the function log returns a double, long double, or float depending on which one it receives. The return statement, as mentioned, can return a value. To return a value, the return statement must be followed by an expression. It could be a literal, a mathematical operation, a variable, or even the result of another function. Remember that the return type of the function prototype and function header must match the data type that is being returned. If not, it will be automatically converted. On the left, on line 8, rate and hours are being declared as variables type double. On the following line 9, you'll see I assigned the call to function getRate to rate. At the moment it reaches the function call, it goes to line 15 to ask, how much do you make an hour? For this example, I entered $7.25. On line 19, next to the return statement, there's a variable called rate. This variable contains the value 7.25 and it's a double. So its function prototype and function header must also be return types double. When returning to its caller, it will return with the value 725 and replace its caller. So in line 9, it will then read, rate is assigned 725. If you don't enter the value returned into a variable, the program will not give an error, but the value returned will be lost, and the program will continue to read in the following line. Next, we have the call to function hour that is in the middle of the cout statement. First, the message, this week you made, will print, and at the moment it reaches the function call, the program goes to line 22 to execute the function hour. The function hour receives 725 as an argument, then declares hours as a variable type double, prints how many hours did you work this week, and for this example I entered 40. And then on line 26 there's the return statement, followed by a mathematical operation. First, the mathematical operation will execute, and the result of rate times hours will be returned to its caller at where it left off. And remember that in the main, we were in the middle of a cout statement, so the return value of getRate will be printed. A Boolean function is a function that is used for testing. They return a true or a false, a 1 for representing true, and a 0 to represent false. In this program, we're going to send a value into a Boolean function and check if it's between a certain range. On line 8, we declared num, a variable type double. Then the user enters a number between 10 and 20. For this example, the number 12 was chosen. On line 14, there's an if conditional statement with a function call to isValid inside. The program goes to line 22, a Boolean function. Now Boolean functions have data return type bool, as you can see in the function prototype and function header. On line 24, there's an if conditional statement that says if num is between 10 and 20, return